So believe it or not, this is actually a true story. A teacher is sad to be at an all-day meeting and away from his students. While thinking about his students, he watches a standard 12-hour clock. He starts watching when he arrives at 8:30 a.m. and stops when he leaves at 3:45 p.m. Through how many positive degrees does the hour hand move during the teacher's meeting? Express your answer as a decimal to the nearest tenth. Again, true story, especially this part right here. I'll highlight the part that's very, very true. Right here. No teacher I know would rather be at a meeting than be with students. All right. So here's the deal. We know that a standard 12-hour clock has 12 numbers on it, and we know that the number of degrees in a circle is 360. So each hour has to have, well, 360 divided by 12, so each hour has 30 degrees in it. So right away we know we have 8:30 to 9:30, 10:30, 11:30, 12:30, 1:30, 2:30, 3:30. And so right now we have 7 times 30 degrees, which is 70. Sorry, 30 times 7, which is 210 degrees. But then we still have this last 15 minutes, right, from 30 to 45. And so we have and 15 minutes is a quarter of an hour. So therefore, a quarter of 30 is going to be 12 and a half. So you add that together and you get 2. I've done something wrong, haven't I? A quarter of 30 minutes. Half of 30 minutes is 15. Half of 15 is 7.5. That is probably going to make a whole lot more sense to you at home. I was thinking something else, clearly. So we have 210 degrees plus 7.5. That gets us 217.5 degrees. All right. Next problem. Blood comes in 4 types. O, A, B, and AB. I think it has to do with a protein in the blood. Do you know?
I have no idea.
No idea. I'm pretty sure that there's O means the protein is not present. A, it's present. A certain kind is present. B, another kind. And AB, you have both proteins. I'm pretty sure that's how it works. O is the most important because anyone can get a blood transfusion with O. But if you're A, B, or AB, you can only get O or A, O or B, or O and AB. Obviously, for the AB folks, that's really important. The percentages of people in the United States with each blood type are shown below. What is the probability that 2 people getting married will both have type A blood? All right. Well, express your answer in decimal form. So we have 0.4, and that's 1 person, because that's 40%. Excuse me? Times 0.4 gives me 0.16. That one is so easy. All right, this one was the problem that gave the most people troubles. Here we go, and it gets kind of ugly, and it gets ugly for this reason right here. Express your answer as a fraction. So we know that we're going to have to work in fractions only. And to do this, we are going to use the fraction 22 over 7 for pi. So right away we know that our game plan, and I like game planning here, is we're going to take the area of the rectangle, and we're going to subtract the area of the circle, and that will give me the area of this shape. Obviously, I just took all 4 of them and created that. All right, so we know the area of the square is 169 minus, now, since it has an area of 169, we know that this side length is 13 and this side length is 13, which makes the radius of the circle 6.5. not 6.7 for those people who missed it because of that. Not mentioning any names. All right, and so I'm not going to say. So we have 6.5 squared times 22 over 7. All right, 6.5 squared is 42.25 times 22 over 7. 42.25 times 22 is 929.5, I believe. I'm going to verify that. So we have 22 times 42.25. Oh yeah, look at that. Winner, winner, chicken dinner. All right, and that's over 7. But we really, really do not like having a decimal in either the numerator or the denominator. So what I'm going to do is going to multiply both the numerator and the denominator by 2. And I get, since it's already up, I might as well do that. I get 1859. Sure is a very exciting year. Over 14. All right. So going back to my game plan here. I have dropped the mic. I have 169 minus 1859 over 14. Well, you know that you cannot subtract fractions or a whole number and a fraction unless you turn this into a fraction with the same denominator. So we have 14 times 169. Getting this down. And so we have 2,366 over 14 minus 1859 over 14. And you subtract 2,366 by 1,859, and you get 507 over 14. 5 over 7, well, does 2 go into it? Because if we can reduce, we have to reduce. So let's look at it. 7, let's see if 7 goes. Obviously 2 doesn't. Let's see if 7 goes into it. So 7 goes into 50 7 times, carry 1. Does 7 go into 17? Nope. So there's our answer.
Could you do it as a mixed number too?
No, you could not do it as a mixed number because it says express your answer as a fraction. So only a fraction will be acceptable here. Okay.
That's what I got, just in decimal form.
A lot of people had an answer in decimal form. All right, Kyle Orton. Who here remembers the Kyle Orton days?
Oh, I do.
So do I. All right. If it weren't for Kyle, we've never had Debo. More Debo. All right, so what percent increase? So how many more touchdowns did he have the second year than the prior year? Well, he had 3 more. So you have 3 more, and to find your percentage increase, you divide it by what your original number was. You take your increase divided by the original number, and you get 1/6. So the question is, what is 1/6 as a percentage? So I know that 1/6, now I happen to know this one off the top of my head, but I'll just go through this, is equal to 0.1666 repeating. But that is your decimal equivalent. Your percentage, you have to move the decimal place over 2 spaces. So you get 66.667. But if you were to do that, you would be marked wrong because it wants you to use a mixed number. So what fraction is 0.6 repeating? 2/3. So you end up with 16 2/3. Last 2 Indy questions. All right. Yes. So, a little background. You may have heard this in other videos. I first worked at Grant, and when I worked at Grant, I worked with a woman named Cindy Wargaki. Cindy Wargaki. We get Christmas cards from her still. Well, they don't do Christmas cards. They do. The Wargaki family does St. Patrick's Day cards. Why?
Why?
Good question. They do St. Patrick's Day cards because Cindy's husband is of Irish descent. In fact, he has a grandfather who's actually Irish.
Does he weigh 14.5 stones?
Well, I know Mike weighs 198 pounds at the time. So I would assume that these are real numbers for Miss Wargaki's family. All right, so we had an interesting discussion, me and one other mathlete, that there may be two possible answers for this. So we're going to go through this the way I did it. I get the answer that the book gets. I'll show the other students' way of doing it, and if you can see a mistake, let me know, and I will give you candy. All right, now that you're listening. All right, I have to buy candy. We're going to the store next, so I'll buy candy then. All right, so 14 pounds is equal to 1 stone. 1 stone is also 6.35 kilograms. So here's what I did. I took 14 stones and turned it into pounds. So 14 stones. 14 pounds per stone, and he was what, 14.6 or 14.5 pounds. So that means his grandfather was 203 pounds. Mike is 198 for a difference of 5 pounds. Right? And so what is 5 pounds in kilograms? Well, a kilogram is 2.2. So you do 5 divided by 2.2, and I get 2.27. And so that's the answer I got. Now, background knowledge. You are expected to know that 1 pound equals I'll start over again. I had it backwards. 1 kilogram is equal to 2.2 pounds. So a kilogram is heavier than a pound. Now, the other student did this. He converted everything into kilograms. So, a stone is 6.38, right? Sorry, 6.35, thank you. I don't know what I was looking at. So we have 6.35, and we multiplied it by your 14.5 stones. And so we get, whoa, that's big. So you get, I'll do this in green, 92.075 kilograms for the grandfather. Well, how many kilograms are in 198 pounds? So 198 divided by 2.2 is 90. So if you subtract these, you get 2.06 rounded kilograms. Yes? Sorry, what, 207, I found. That's a difference of 0.2 of a kilogram between this answer and this answer. So that's a good question about the rounding. Typically, you don't round until the very end. You keep all your numbers until you're actually writing your answer, and then you do the rounding. If you do rounding as you go, you could get a wildly different number. So that's a great question.
Why do you have to, which is 2.07 instead of 2.075?
Oh my God. My bad. So you're saying it should be this?
No.
I think it should be this.
Sure.
Do you know why?
Why?
Because when you do subtraction, you get 2.075. But the answer wants to go to the hundredths place. So that's rounded to the correct hundredths place. Okay? All right. So notice how there's a discrepancy. And I believe the origin of the discrepancy is that 1 stone doesn't equal exactly 14 pounds. It's 14 point blah, 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 blah. And this decimal will continue. And also that 2.2, that we talked about, it's actually 2.21 dot. So by rounding as we go with these conversions, you get a wildly different answer. So it fits in with your question. I realized that you had more information on that problem than you probably ever wanted. Yeah, I'll get rid of that equal sign. All right. The following table shows how much water is leaked from a faucet if a family left for 5 days. How many gallons of water would have leaked during their absence? Well, clearly, it's a difference of 5 cups over 2 hours, and and so here we have 7.5 over 3 hours. We see we have a constant relationship. What kind of relationship is this?
Linear.
This is linear. All right. And so this is our rise. This is our run. What is our slope? Well, rise over run, 5 divided by 2 is 2.5. And as luck would have it, it's there too. All right. And so, and then we have, and that's times the hours. And if I follow this pattern backwards to 0, I would get 0 cups leaked. So plus 0, I don't need to write plus 0. So now we have the last piece. How many hours are you gone if you go for 5 days? And we are going to assume it's, if you leave at 6 in the morning, you're arriving at 6 in the morning, exactly 5 days. So we have 5 times 24. So that's 120 hours times 2.5. And so you get 300. But 300 what? 300 cups.
I just guessed.
Now, if we have to go to your gallon man, we will. But I hope not. There are 6, so there are two cups in a pint. I don't want to go through the whole thing. Essentially, there are 16 cups in a gallon. So then we're going to divide this by 16.
18.
And you get 18.75. So you will lose 18.75 gallons of water during your absence.